これの彼の方が、テクノロジーのご説明が少し移りましょうか。湿度ガスとか平気です。平気です。少しです。大丈夫です。
今日のプレゼンテーションいつからあるんですか。
いやもう大丈夫です。
So here is the AR.Drone. So it's a quadrotor. It's a quadrotor with 4 brushless motors. Okay. This is the indoor configuration for flying.
こちらがインドアで、ヘリコプターを飛ばす場合のシールドになります。
So, so the indoor configuration is perfect. Is perfect for protecting the walls and equipments and also the propellers. To fly outdoor,
外で飛ばすにはこちらの
you need the outdoor so that you can fly against wind
で風に乗って飛ぶことができます。
and go much faster.
ですごく早く動けます。
Whereas this configuration is good for indoor.
こちらになりますとインドアですね。
But it slows
ちょっと動きが遅くなります。
The AR.Drone has a battery allowing about 15 minutes, around 15 minutes flight time, and it has electronics and sensors to allow complete auto stabilization. Complete auto stabilization means altitude auto stabilization, and this is done thanks to ultrasonic sensors, transmitter and receiver. This measures the altitude, and so we can stabilize it so the pilot doesn't have to manage altitude, only if he wants. So for managing the angular rate of the AR.Drone, we have gyrometers in X, in Y, and in Z, in order to manage the angular rate of the drone. So you don't have to manage it when it falls. Gyrometers are mandatory because this formula of quadrotor is very unstable. So you cannot manage roll and pitch angular rates manually. It's not possible with a human. So to manage the angle, not the angular rate, but the angle, we have an accelerometer that tells us where is the vertical direction. So we can control the angle of it. We can stabilize it with this angle or with the zero angle, but we can manage to have this angle for going right, for example. And so we have a camera looking beneath the AR.Drone. There is a small camera, 60 frames per second, and we compute the speed by combining the camera information and the ultrasonic measures. This gives us the XY speed of the AR.Drone, allowing us to stop it automatically. So all these sensors allow us to simplify piloting the AR.Drone because when you release the commands, it automatically stops and stabilizes by itself. Before this technology that is proprietary to Parrot, we designed everything in this. A human had to train hours and hours on a computer to pilot such a model. There is on the board there is a Parrot processor, and there is Wi-Fi. There is a Wi-Fi technology, so you can connect over Wi-Fi and control it over Wi-Fi. There is a frontal camera here with a wide-angle optic, and we stream the video of this camera over Wi-Fi to the iPhone. We can toggle for the streaming. We can toggle between this camera and the camera below the AR.Drone. So we can stream both cameras and have both views on the iPhone. With the frontal camera images, we can and thanks to our processor, we can detect tags with it. So we will show you tags. For example, this is tag. This is a tag example, and this is also a tag example. So tag detection allows to design augmented reality games that can be developed on iPhone for renewing the experience and playing varied scenarios around missions or fighting games, races. So there are many possibilities with tag detection thanks to the frontal camera, the camera below also, and the processor. All this information is sent to the iPhone for managing a game, adding effects on the video, and also requiring the AR.Drone to make special movements for simulating it has been damaged, for example, in the game.